Hey guys, so we're going to change things up a little bit today. We're going to talk about my professional, what I do to make a living, because the YouTubes aren't quite doing it yet. But I wanted to show you this because this is something I got from work. This is an artifact from work, and I wanted to show it off just because I think it's neat. So what this is a drive. This is a motor drive out of a glue machine for a low speed high torque application. It drives a motor that pumps hot melt glue through a line to be applied in production, and it just as far as I'm aware, it just shorted out. The supply to this, the low volt supply is shorted out, the high voltage shorted out, everything. It tripped like 3 different breakers when it finally went. And of course there were some intermediate issues too, but that was the big dramatic one. And so I wanted to point out some interesting failure points on this. So let me get where I can hold it and show it to you at the same time. Now I am not a drive expert by any stretch of the imagination. I have really, in my opinion, just a basic rudimentary understanding of all of the components that we see here. But you can see on the back side we have a battery of transistors, and over here, and I also couldn't find any paperwork on this to show me a diagram. I did discover that the silicon layers with the solder traces and everything, I'm pretty sure is a 3-layer system where you have the layers you can see here, you have the layers you can see on the back, and then there's a middle layer, and they're all insulated from each other, so it's really hard to visibly just look at it and trace what goes where. Some of the stuff like this jumper right here goes all the way through to the other side of the board, but some stuff doesn't. So it depends on how it was laid out and how it was designed. It's pretty interesting and it's pretty efficient. But in the course of trying to figure out what caused this drive to fail, I took the heat shield off the back of it, and I took the cover off. I thought I had a picture of the cover that I was going to share so you guys could see the model number. It's a lenze drive. But apparently I've lost that picture, so I don't have the exact model number and everything. There's the information on the drive itself, but you can see this transistor has come apart a little bit more than it was when I took it out, just for me messing with it. But the central post right there, I don't know if you can see it. If I can, let me see if I can zoom in real good. That central post, before I even started poking at it, had completely burned out. It was gone. And so, you know, that's something really dramatic. And you can see on the other side, there's artifact from that failure. That arc actually burned the backside of these are, I believe, capacitors. Most of everything you see on here, you know, you have these transistors, but most of these are capacitors. You have these big ones. You know, you have this processor chip. This vertical chip right here is for a CAN. It's for a CAN bus system, so it's got its own processor to organize the data packets as it goes through the CAN network. But this would be the processor for this specific drive. Pretty neat system, because the glue machine actually it installs its own information on there. Like it's got a built-in setup for it. It's really easy and super fascinating to use it. I've had I haven't, because I'm not very good at it, but I've been a party to having to download to these drives to get the parameters set appropriately into them, and having to map from your PLC, your controllers into these can be a real hassle. The glue machine that we were using this on had a really great setup straight through the HMI. It was super easy to use. This is not a commercial for them. I'm just, you know, I thought it was really cool that they put that much time and effort into it. You don't always get that. But this, if I recall, is the only artifact on this side of the board. And then we turn around the back side, we can see, let's see if I can find it again. Here you go. So this area right here, you can probably see there's a little smudge from where I've been handling it, but this looks like the major failure right here, which is where it's on the back side of, you see these 2 big capacitors right here. That's where this big space is, and I believe that's where these nodes go to, and then somehow you have these I can't remember if these are solid state relays or resistors or fuses, but whatever happened here, this major arc here, I think this is your relay, and then these are your resistors that control the different subcircuits within. But whatever happened here daisy chained across all three of these components and burned them all out. They have diagonal char marks across all three of them. And that was really the only, without an oscilloscope or, even some information, a wiring diagram, it's hard for me to really figure out what caused the failure. The only thing, it was either an internal failure on this board, which was actually newer than the one I put in to replace it, or it was just overloaded. But it's interesting to me that overloading it, from a clog in the glue line or something like that, wouldn't have just shut this off. There should have been internal safeties that would have stopped this exact thing from happening, unless some component in here was already flawed. Which happens, but I love tinkering with this stuff and taking it apart and just trying to understand it a little bit better than I already do. Leave me a comment or something if you are a drives expert and have worked with these drives, or maybe know a little bit more about them, or have an opinion on lenze in general. I've had good experience with lenze, but I'm not very good with getting online and working with them. Anyway, my name's AJ, and I'm going to get back to video games. All right. Anyway, bye.